Welcome to the Overland Journal podcast. I am your host, Scott Brady, and for this week, we have a Principles of Overlanding Vehicle Electronic Systems. I'm joined this week by Mark Bruce. Now, Mark is an engineer, he's a product engineer, and he works with a company called RedArc. Now, we don't talk about RedArc products, we don't really talk about RedArc as a company, but they are considered one of the preeminent products, one of the best products in the segment. And because it's one of the most high-end products, they have engineers like Mark that are available to talk through subjects as diverse as solar, battery isolation, dual battery systems, lithium versus AGM. So we go into a lot of detail around how to fuse electronic systems. We talk about battery isolation. We talk about the right kinds of systems to use. We don't focus on any individual products in particular. Focus more on the principles, on the systems that you need to have in place, and the really core tenets of good electronic system design. So we really have a great conversation. I learned a lot in my conversation with Mark, and I think you will too. So please enjoy our Principles of Overlanding Vehicle Electronic Systems.
What is it about the backcountry? What drives us to leave a perfectly good road and head off into the wild? Maybe it's the promise of new experiences and discoveries, the allure of the unknown. That's why we do what we do. It's why we are a pioneer in building off-road, off-grid RVs. And it's what makes our Backcountry series models the perfect companion for a life of adventure. These vehicles feature off-road capability, reliable off-grid power, and freshwater capacity, plus multifunctional layouts that give you enhanced gear storage and workspace, and the comfort needed to relax in the kinds of places where our Backcountry series vehicles thrive. Take, for instance, the Echo, which introduces off-road camper van utility to a rugged yet spacious Class C. Or the Revel, the ultimate adventure-ready van, boasting up to 7 days of fully off-grid power. And then there's the Solus, a supremely flexible and thoughtfully designed camper van that has everything you need, and a few things you never knew you did. The right vehicle can open up entire worlds, but with a Backcountry series RV, no matter where you set up camp, you'll still find all the touches of home. Because in a world where less is often more, it turns out that sometimes more can still come in pretty handy. Explore our Backcountry series. Winnebago RVs, purpose-built for life beyond the open road.
Well, Mark, thank you so much for being on the podcast with me today. So this is going to be kind of a Principles of Overlanding on electrical systems. It's a rare opportunity for us to have access to your time.
Thank you.
You and I have met each other many times over the years. I'm trying to remember if we actually spent some time together when I visited you guys in Adelaide. I think so. I think I did see you there as well. And that was incredible to take a walk through the facility and see just what it takes to make products like this. And it's a very difficult thing to do. So when we talk about electrical systems for vehicles, I thought it would be good to go through some of the important use case scenarios about why you want to upgrade some of the electrical systems of your vehicle. You know, many vehicles that come from the dealer now, you know, they'll have a 12-volt outlet in the back.
Yeah, sure.
You know, some of them will even have an inverter possibly on board. One of the big challenges that we find with that is there's twofold. So normally the inverter is not powerful enough to operate many of the things that we need to have in camp. Before we started recording, you and I were talking about a coffee maker.
Correct.
And I don't know about for you. I mean, I know coffee's a thing in Australia.
Important. It's very important.
So for me, it's very important.
And we're often referred to as the coffee snobs.
You are.
Yeah,
and you order a flat white. Yeah. Which it took me a while to understand what that meant, but it's basically a latte.
Correct.
So
same, right? Basically. Yeah.
And then there's a long black, which is just basically black coffee. That's a Americano. That's right. Exactly. But then they all taste great. But you're not going to make espresso on 400 watts.
No.
So you need to have a larger inverter. And then the other thing that we find, and this is where people really run into trouble, is that the majority of cases, the 12-volt outlet that's going to be available in the back of an SUV, the wiring is going to be underrated for most fridges, or it's not going to be able to take the startup amperage of many of the fridges.
Right, yeah.
And then when you turn the car off, normally within a few minutes, you're going to lose those accessory power outlets. So let's talk through what you see as best practice to address both of those scenarios. I need a good inverter.
Yeah.
I mean, I don't need a blow dryer, but some people do.
Yeah.
So a blow dryer, 1,000 watts, 1,500 watts. Coffee maker, 1,000 watts, 800 watts.
And
60, and then sometimes up as high as 2,000 watts, but depending on the coffee maker. And it's also really good to look at those stats of whatever you're buying, because there are going to be things that are going to be more efficient than others. So let's talk about the scenario of plugging in the fridge in the back of the vehicle. In your mind, what do you think is some of the best practice ways to address that?
Well, for example, your start battery is there to do one job, and that's to start your truck.
Yeah, reliably every time.
Reliably every time. And the alternator has two jobs. One is to maintain the fully charged start battery, not to recharge it, to fully keep it full.
Yeah.
And the other thing it has to do is run your electrical loads whilst you're driving.
Yeah.
So if we think back years ago to the old F-trucks and things, they used to have maybe an 80 amp alternator.
Yeah.
But now they've got like 280 amp alternators.
Sure.
It's not so that they can put more power into batteries. It's so they can run more electrical loads in the vehicle.
Some vehicles have massaging seats. I mean, they can take a lot of power.
Heated seats and all of these computer-controlled gizmos that they have that we can't live without.
That's
and
right.
now even inverters in the back of these vehicles that are exceeding 2,000 watts.
Some of them do.
Let's be honest. Like, some of these trucks are amazing. But
power a house with them.
Yeah. But they only run whilst your truck's running.
Yeah.
I don't know about you, but do you want to keep your food and your drinks cold when the truck is off?
Yeah, right, exactly.
It's important.
Yeah.
So we can't afford to reduce the charge in our start battery. We can't afford to do that. So we've got to have another means of housing energy to be able to support our lifestyle.
Yeah.
Our lights.
Yeah.
Our lights that we use whilst we're camping, our refrigerators, our cooling fans. We need to keep things charged, like our mobile devices or whatever it might be. Now that
charge up a drone or a camera or whatever.
We even want to run coffee machines now. I mean, we can't do without our lattes or our Americanos when we're out in the sticks, right? So let's.
You're not wrong.
Yeah,
you're not wrong.
We've got to keep the power housed somehow. So it's really important for us to have a second means of doing that, and that's where auxiliary batteries come into play.
Well, and we're even seeing a lot of interest in induction cooking now. Like this trailer that we're in here uses an induction cooker. It has a 12-volt air conditioner.
Yep.
So there's more and more systems that are being powered off of 12-volt at higher efficiencies. But that means you got to have bigger and bigger house batteries.
Yes, sir.
So I think that's a really good point. Is one of the main reasons why we consider a dual battery system is to protect vehicles starting. Because the reality of being an overlander is, like when I did the Australian Bight with some of your team, when we were out there driving through the Australian Bight in southern Australia, we were very remote.
Yeah.
Very, very far from the nearest town.
One of the straight roads is like 145 kilometers long straight.
Yeah,
no
without
curves.
a turn.
Without a turn.
Exactly. So you're really, really out there.
Yeah.
And what you want to make sure of is that when you turn that key the next morning, that the thing starts up.
Right.
And if you decide, hey, we're going to spend a couple days on the beach, You want to be able to do that.
Yeah.
And one of the ways to do that is with a house battery. In your experience, what are some of the lower expense ways of doing that? Like a lower expense battery, what are some solutions that you've seen to run these house systems that you think are a little more affordable?
Yeah, look, AGM batteries, whilst lithium batteries are so popular now, it's a real buzzword. The AGM battery, like the lead battery, is not dead.
Yeah.
Lead's not dead necessarily.
Yeah.
It's affordable.
Sure.
But the rule of thumb is with AGM batteries, as an example, and please, all my AGM friends out there, don't get angry with me. But essentially, the rule of thumb is we have 50% of our amp hour capacity available to us.
That's right.
When you've got an AGM battery.
50% depth of draw.
Correct. So if we reduce the charge in that battery beyond 50% charged, we greatly reduce the life expectancy of that battery. So when we're trying to, suggest to somebody how many amp hours that they need in a battery, we've got to work out if they're using AGM batteries, that amp hour capacity, they only have 50% of that.
That's
so
right.
maybe we might need a bigger battery. Whereas if we went lithium, we could probably have half the amount of batteries, reduce the amount of space,
and weight, significantly lighter,
and not necessarily cost us a whole lot more.
Yeah, that's a good point. And one of the ways for those that are listening, there's some things that we can look at around knowing what that 50% depth of draw is, and the easiest way to do that without a bunch of expensive diagnostic or a bunch of expensive gauges is these are 12-volt systems.
Yep.
So an AGM battery will typically have a higher float than a standard lead acid battery, and that float will be somewhere around 13.2, 13.4 volts or so, approximately in that range. So you have to work with from 13.4 down to 12.
Yeah.
So when you start taking your battery down below 12 volts, and if you do it very often, so if you get into that 11.8, 11.6, 11.4, you're starting to greatly reduce the lifespan of that battery. So we have to remember we're starting off with a 12-volt system.
Yeah.
So the 12 volts is zero.
Yeah. So I can share a really classic example with this, and it's roughly relevant to a battery specific gravity level of the electrolyte in the battery, right? So let's say we have a fully charged battery at 12.8.
Okay.
At 12.5, we're essentially 70%.
Yeah, that's right.
75%. At 12 volts, we're zero. So we're 50% at 12 volts.
That's right.
Then at 10.5, we're zero.
Yeah.
So a 12-volt battery, a lead-acid battery, AGM battery, at 12 volts is essentially 50%. That's a rough scale. 12.8 full, 12.5, 75%, 12 volts, 50%. As a rough scale for a lead-acid AGM battery.
And that's just really important for people to remember that, to use that as a guide is if you set it up where 100% is whatever the float is and 0 is whenever it stops providing power, which some fridges, like an Angle fridge, will run all the way down to 10.5 volts.
Yeah.
So it will flatten your house battery. Yeah. And you do that a couple times and they won't come back.
Yeah.
And even if you start playing in those high 11 volt, 11.6, 11.5, you're going to greatly reduce the lifespan.
Yeah.
Yeah, that's been my experience. Okay, so it seems as if AGM might be less expensive, but do your research because you may find that lithium is in fact. So what is a good size lithium that you have found for most travelers?
Look, if you're starting at 100 amp hour capacity, that's essentially the sweet spot.
Yeah.
But, there's been a lot of talk out there where, I've got a 100 amp hour lithium battery and I've got 100 amp hours available to me. I can fully discharge that battery. Well, not necessarily, Scott. I kind of think about your battery is like your fuel tank in your truck.
Yeah.
You might have a 40-gallon fuel tank.
Mm-hmm.
But do you use the full 40 gallons? Or do you, go to the gas station when you've got a little bit left in the tank?
That's right.
So batteries are no dissimilar to that.
Mm-hmm.
So we want to make sure we've always got a little bit left in the tank, especially with lithium.
Yeah.
Before we let them get too flat. We never really want to go too flat. But the majority of lithium batteries nowadays have that sort of technology in them, so they don't go too flat.
Yeah, and it'll just shut itself off before they get too low. But to your point, the reason why we want to have reserves of water, we want to have reserves of fuel, we also want to have reserves of power, is that there are emergency situations that can occur. Yeah. So if you come into an emergency situation and you've been just banging on your battery and it's really low, but now you need to start using the Starlink to communicate with maybe a remote medical doctor because you're having a situation, or you've had a mechanical with the vehicle and now you're using Starlink or your sat phone, or you're using other things that you need power on, or you're using tools and power tools that need charge.
Sure.
You want to have that reserve capacity for those unexpected events that can occur.
Yeah, definitely. So, Starlink's a classic example. We've got a new van here at the show this week, and we're using a Starlink. It draws anywhere from 10 to 12 amps when it's running.
Yeah.
So, it does consume a bit of energy. And if we think about that, 10 amps for an hour is 10 amp hours.
That's right.
How long do you want to have your Starlink on?
And if you leave it on overnight, which a lot of times people will do, or they'll forget, you could wake up in the morning and you're down 30-40% left on your battery.
10 amps times 10 hours, that's 100 amp hours.
Yeah, that's right.
And you're done.
That's right.
You could only have a 100 amp hour battery, you're fully flat the next morning. No one wants to wake up to that.
No, exactly. And then you're trying to now get out solar, or you're trying to run the vehicle to get the alternator providing current to the battery. And one of the things that I did with the Starlink that I own is convert it to 12 volts.
Yeah.
So that pulls it down to like that 3.5 amp or so.
6 amps or so.
Yeah. Well, even 3.5 amps is what I'm getting out of it, because you don't have that
conversion at the front,
the parasitic loss both directions. So it really does help with that. So you normally like to look at, it sounds like you like to look at a lithium ion house battery around the 100 amp hour capacity for most travelers.
Yes. So if we think about a refrigerator, like a 12 volt fridge, and let's say that 12 volt fridge is drawing on average, say 3 amps. So if I was drawing 3 amps constantly for an hour and I never turned off, that would be 3 amp hours consumed. If I ran 3 amps for, say, 24 hours, essentially, what's that? 72 amp hours.
Yeah.
But fridges don't stay on all the time.
They don't run the whole time.
They cycle on and off.
Yeah.
So if your refrigerator is cycling on and off, let's say 50% of the time, because we haven't got it on freeze, we've got it as a refrigerator.
Sure.
Let's say we have it, it's drawing 50%, so that's 36 amp hours.
Yeah.
So if that fridge was running off that battery constantly over a 24-hour period without any other charging sources supplementing the energy consumed, that could be, say, 36 to 40 amp hours.
Yeah.
We're almost at that 50% consumed.
Right.
So how important is solar to be topping you up whilst you're camping during the day?
And one of the solar panels that I really like, and it's actually the one that I used in Africa is actually the same one that you guys sell. It's a foldable solar panel, and it comes out about I don't know what it is in centimeters, but probably about 18 inches square.
Yeah.
And it slides into a bag, and it's small enough that I was actually able to carry it on the plane with me.
Well.
I didn't think it would go well through the check bags, or if it would even arrive at all. $1,600 solar panel. But the thing that I really like about that panel is it's basically the same size of a windscreen.
Yeah.
So when I had it on the Grenadier and I laid it flat again, or same with a 70 series, or it's very similar size to a windscreen, which puts it a little bit at an angle. And if I remember, it was 160 watts.
Yeah, okay, yep.
So, does that sound right?
Yeah.
Like the one that you guys
there's a 160, a 240, and a 300.
Yeah, and is that, when you've got this 100 amp hour lithium ion battery, what do you normally recommend for the size of the solar panel for a system like that?
Look, I'm really conservative in my calculations, because the last thing I want to do is mix up a customer's expectations versus their capabilities.
Yeah, sure.
So we've got to be really careful. So I generally suggest to customers, we've got the ability to produce 5 amps of charge per 100 watts of solar.
Oh, sure.
So
mixed conditions.
To dial that down even more, it's for every watt of energy, of solar energy, we can generate 0.05 amps of charging power.
Sure.
So 100 times 0.5 is 5 amps. Right. So 5 amps of charging power from a 100 watt solar panel. If I've got a 200 watt solar panel, that means I can generate 10 amps.
So now you're maybe running the fridge at 50% duty cycle, and you're also running your Starlink for a couple hours a day.
Yeah.
And then you're still able to charge your laptop and a couple other things, and you're keeping the battery topped off.
Yeah.
So it sounds like you normally like to have the solar panel for that kind of a setup. Call it a 160 or a 240, somewhere in that range. Unless you're running fridge and Starlink and a bunch of other systems, then maybe you want to go a little bit bigger.
My rule is one fridge and some LED lights, 100 amp hours, and a minimum 120 watt panel.
Yeah.
And if I'm expecting to be moving around during the day, or traveling on an adventure, you can't beat the DC charging capabilities that are in the market today.
Yeah, because you can so quickly charge.
Oh yeah.
So there are many different sizes, so that's good. So we've talked about the battery. Look at the difference between AGM and lithium. Are you really saving any money? Because you're certainly saving weight, and
space, right?
Yeah, and space, exactly. And which can be a factor on some of these vehicles.
Huge.
Yeah,
the space is at a premium when we're traveling.
It really, and so is payload.
Yeah.
So now we know we need to be in that at least 120 watts of solar. Sounds like 240 is going to be pretty good if you got a couple systems running, or you're banging on that espresso maker too much.
Yeah.
And then we want to be able to provide good charging current while we're driving. And one of the things that I found that's come onto the market in the last 5 years or so with some really good solutions is you've got a DC-DC charger, but it also is your solar charge controller.
Yeah. Definitely.
And help the listener know the difference between a standard solar charge controller and an MPPT solar charge controller.
So MPPT stands for maximum power point tracking. So what that does is the maximum power point tracking solar regulator gets the most or the best voltage point of that solar power or that solar voltage where it can subtract the most amount of current. It's the maximum power point of that solar array where we can get the most from that solar panel. So we're maximizing the power that's available from your solar panel.
And again, because we're trying to look at what are some of the less expensive solutions. Do you feel like people really need that, or do you think it's become common enough now that you really should probably have it? What are your thoughts?
Look, MPPT, it's great. It's the new buzzword around solar. We have people coming up to us all the time. Oh, is your solar regulator MPPT? Look, PWM does just fine.
I think it does.
In smaller systems.
I think it does.
The MPPT really comes into its own when you're in the big household systems, but the smaller systems, you probably won't see a lot of difference in the performance on a smaller overlanding application.
I agree.
But however, if you've got maximum power point tracking available and it's in your system, you're going to use it because it is the better system or the more efficient system.
Sure. But it's good for people to know that you don't have to have it.
No.
That it can be considered an upgrade, or it can be considered not even necessary. The other thing too is, as these systems become like an MPPT in general is going to be a larger charge controller than an integrated standard solar charge controller. Sure. So I think either one works. Not going MPPT might save you a little bit of money, but it certainly is something to be aware of if you're trying to go with the smallest panel possible and get the most out of it.
Sure.
That's certainly something to consider. But I like the fact that a lot of these DC to DC chargers are integrating solar too. I think it makes it easier for the consumer.
A lot easier because you got one point of connection, right?
Yeah.
So let's have a look at like what solar is going to give us compared to what our DC charging is going to give us. So, for example, if I've got 200 watts and I'm getting 10 amps from that 200 watts, in theory, what time span of the day can I really get that 10 amps? And basically, we rely on 5 hours of really good charge throughout the day, right?
Because the sun isn't that low on the horizon;
that's right.
it's up high.
And are we really following the sun when we got the the panel flat on the roof of our Grenadier?
No.
Possibly not, right?
No.
So let's say we've got 5 hours to produce 10 amps. We're going to replace 50 amp hours over 5 hours.
Right.
However, if you get a cloudy day or you're parking in the shade, you're not going to be generating that power. And no matter how much somebody says their solar panels are shade tolerant, the part of the equation is it's a solar panel. If it's not in the sun, it's not giving you what you paid for,
That's
right? So with DC-DC charging, we can give you maximum charging power whilst you're driving. So where a 200 watt panel might take us 5 hours to replenish 50 amp hours, if I've got a 25 amp DC-DC charger and I'm driving for 2 hours, 2 times 25 is 50 amp hours.
You're done.
2 hours of driving. And when we're out exploring and overlanding, we're driving more than 2 hours.
For sure.
Let's be honest.
For sure.
From campsite to campsite, we're out exploring. This is what we're doing. So let's capture that energy, what we've got available to us now. So when we're back at the campsite, we don't have to supply power for 24 hours. We don't have to worry about solar. We can rely on solar to maintain rather than trying to recharge.
For sure.
And then use all of our creature comforts throughout the late afternoon, throughout the evening, and then do the same again. Rinse and repeat.
No, that's really true. Absolutely. One of the things that I found with the DC to DC chargers is there's a lot of different amp capacities available. I've seen 5 amp, I've seen 10 amp, I've seen 25 amp, 50 amp, and of course up from there. I normally find that if you're wanting to charge while the vehicle is sitting, you're going to want to have a higher capacity DC to DC charger, because if you have, let's say, a 100 amp hour DC to DC charger, or a 50, you're going to get a lot more charging done in a short amount of idle time for the vehicle. So think about how you use the DC to DC charger. There's downsides to it. So if you go from a 25 to a 50, it's more expensive, takes up more space, generates more heat. So figure out what kind of charging that you need. If you find that you drive just about every day and you come and you drive for 4, 5, 6, 7, 8 hours, you're probably going to be fine with a 25 amp unit. But if you like to stay in camp and you want to use your vehicle's alternator like a portable generator, and you want to try to top off your battery with 30 minutes or 45 minutes of idle time a day, then you're going to want a higher capacity unit to give you more current in that period of time. What are your experiences around that?
So we've also got to be careful. What's the battery manufacturer's recommendation for maximum charge current? Because that's really important. With lithium, we're a little bit more relaxed with it because they can accept a lot faster charge.
Oh, I didn't know that. That's interesting.
They can.
Even more than an AGM?
More than an AGM,
Interesting.
So what you got to be careful of, though, is do we necessarily want to be fast charging our batteries all the time? You get the old scenario where you got your cordless tool batteries, and you whack them on a fast charger all the time. The life expectancy of that battery is reduced because you're pumping that charge back into it really quickly. Now,
let's pause for a second on that, because that's really interesting. So, with lithium, are you finding that you're tending to recommend a little bit more of a measured approach around that, maybe 50, 25 amps?
So normally for a single battery, I recommend to customers, normally the 25 amp is plenty. Like I said, 100 amp hour, I consume 50, 2 hours drive, I've replenished. And it's not necessarily fast charging all the time. I mean, hell, we've got a battery now that can accept a maximum charge current of 135 amps. But I don't necessarily want to be charging it with 135 amps. Not that I've probably got the ability to.
Because an alternator at idle, you'd be lucky if you're getting half of the rated current or something.
But again, we don't want to go directly from an alternator. We've got to go through a DC-DC charger. But I guess the size of your DC-DC charger is relevant to your battery capacity. So a rule that I use, if you've got a single battery, no matter whether it's an AGM or a lithium, I normally suggest that a 25 amp charger is plenty. on the AGM side. But if it's a lithium, a single lithium 25 amps is fine. But if the customer's using a lot more energy, maybe they up to the 50.
Sure.
Because, look, if my battery can accept a maximum charge current of 135 amps, 50 amps is going to be way under the maximum.
And it'll like you said,
Charge fast.
It'll charge fast, and it'll keep the battery live for a long period of time. What do you think is some key considerations around DC to DC chargers? One of the things that I look for is vibration resistance. Not all of them have good vibration resistance. I also tend to look for units that either have good insulation or potted and sealed.
Yes.
Particularly if it's going to be installed underneath the hood. What are some other things, or even you could talk at length about what I just brought up, but what are some of the things that we want to look for in a DC to DC charger around features?
Well, features, for number one, you need to ensure that it's going to be compatible with your vehicle. So if you've got a modern day vehicle, say MY16 Plus, chances are it's got some sort of smart or variable voltage alternator on it. Okay, temperature compensating even. So having something that's compatible with the modern day alternator is very important. Another rule that I use is, like you mentioned before, we have 50% of our alternator capacity available to us for DC-DC charging circuits. So as an example, if I've got some Toyota four-wheel drive that's got maybe 100 series using old school technology here, and it's got 120.
Great truck though,
and fantastic truck, and it's got 120 amp alternator. I've only got 60 amps available to me for DC-DC charging.
Sure.
So in the case of a good quality 50 amp DC-DC charger, that's going to draw a maximum draw maybe from the vehicle around 50 to 60 amps.
Sure.
So you can draw one for the truck.
Yeah.
Or let's say, what if these customers, these consumers are also pulling a trailer with a battery system in it?
Yeah.
They've got to keep that in mind. So they need two BC or DC-DC charging circuits, right? So they need one for the truck and one for the trailer.
Yeah,
so you shouldn't be putting two 50 amp systems in, because that could be drawing, say, 110 to 120 amps.
And then you're not leaving enough amperage available for the vehicle systems
to run the truck and to maintain that fully charged start battery.
That's right.
So we've got to keep that in mind as well.
No, that's really good feedback. What do you feel is some of the things that have to be considered for under hood mounting?
Well, if it's under hood mounting, it's got to be heat tolerant. It's got to be tolerant to moisture. And it's got to be tolerant to vibration.
Yeah, a lot of vibration.
So
especially in Australia, those corrugations.
It's terrible. And you've got to have some sort of your electronics have to be encapsulated in some sort of silicone or some sort of potting mixture to ensure that it's going to be able to handle that. Getting the charger out of the heat of the engine bay as well, as much as these charging systems can handle heat, getting them out of the engine bay, maybe mounting it forward of the radiator but behind the grille to allow for some airflow.
That's clever.
I mean, most of these things are, or some of them are water resistant or waterproof.
Yeah.
So getting it out of the heat of the engine bay, but also not going too far away from where the auxiliary battery is. Remember, we might be able to overcome voltage drop on the input, but once the charge leaves the charger, we have no control.
That's right.
So we want to ensure that the charging system, or the DC-DC charging system, no matter what brand it is, needs to be positioned close by the auxiliary batteries that you intend to charge.
Because you're putting out so many amps, a really long run of cable, you could have a significant voltage drop.
You're going to lose,
And that's where it's important to make sure that you're going with the correct gauge of wiring to make sure that you're minimizing the voltage drop, the quality of the wiring that you use, the number of strands that are within the wire, all of those things, the quality of the insulation, all of that will contribute to a better result.
Yeah, and the fusing.
Let's talk about that.
That's important,
because people burn trucks down all the time.
And I've seen some terrible practices.
Yeah, so that's really important. That's a great idea. Let's talk about how we properly fuse a DC to DC charger.
Okay. To give you an example, what I've seen a lot of is where the the DC-DC charger is positioned, people place a fuse right at the charger. So the distance of the cable running from the power source, which is in this case the start battery, to the DC-DC charger, there is no fuse between the positive of that start battery to that fuse holder.
That's right.
So placing the fuse close to the DC-DC charger means that you've got protection from the fuse to the charger.
That's right.
And, we might be talking 6 inches.
That's it.
Max. Whereas on the other side of it, we might have 5 feet.
That's right.
Of cable. So whenever you're doing an installation, you've got to place the fuse protection close by the power source.
At the power source.
And
That's right.
the power source is not the DC-DC charger, it's the start battery, i.e. alternator power. Yeah. So we place the fuse close by the start battery.
And then once it comes out of the DC to DC charger, depending on the manufacturer, they may have internal fusing, they may have fusing integrated with the DC to DC charger, or you may need to place the fuse at the output of the DC to DC charger.
It's got to go close by the start battery. The auxiliary battery.
Yeah.
Because the fusing is there to protect the wiring.
Yeah.
Not necessarily the charger.
Yeah, sure.
In the case of like our products,
I like to do it on both ends myself.
Yeah, one close by the start battery, and one close by the auxiliary battery, because like with most products, or you'd hope most products, the products are current limited in themselves anyway, so they have that protection inbuilt.
That's right.
So you put one close by where the power sources are, because without the batteries, that charge is not doing anything.
Sure.
It's got no energy in it.
That's right.
So the fuse needs to be close by each battery.
So I would normally, when I would do an installation, so I would put the fuse at the starting battery to make sure that protection of that length of cable is protected. Then I would put one at the auxiliary battery from the output of the DC to DC. But I would also typically put a fuse right at the DC to DC charger, because I have found that if you had a small arc, or if it was just barely kind of clicking on and off, that you could actually, I have had some damage done. Now maybe your units are protected against that kind of
protecting
stuff.
Sort of
So
stuff.
and the reason why I say that is I've gone with a bunch of different types of systems, and some of the dual battery systems that I've used have been the traditional starter solenoid style.
Yeah.
And those don't know that something has arced off in between the two.
No.
Whereas, like, for example, your DC to DC, it's going to have that intelligent control. So if you're going with a mechanical battery combiner, or if you're using a dual battery system that many of them use, like a starter solenoid style, you may also need to fuse at the dual battery system.
Yeah. It's in the rule that I've used all throughout my years, 35 years in the industry, is placing the fuse close by the power source, which is the batteries, is to protect the cabling from any shorts.
Sure.
The product itself is going to take care of things. They're current limited themselves anyway.
And that makes a lot of sense. And maybe it's another reason to consider these more advanced DC to DC chargers over the more traditional solenoid style dual battery systems.
Solenoids aren't a charger. They're a mechanical switch that simply link batteries together. Right. And and how often is our start battery identical to our auxiliary battery?
Yeah.
Hardly ever anymore.
That's right.
And whether it's a different brand, it's a different chemistry, it's a different capacity,
different float voltage,
it's in a different location.
Yeah, sure.
So how does the alternator know to send more charge down to that auxiliary battery in the back of your Tacoma, rather than the start battery up the front? It doesn't know. So the electricity takes the path of least resistance, just like water does, right? The battery that's the furthest away is going to get the least amount of charger, and that's where DC-DC chargers come into their own. They have the ability to boost, to multiply that energy coming in and provide the battery with the energy that they need to get charged the fastest.
That's great insight. That's something that I wasn't aware of. So thank you for sharing that, because now I have a better understanding of why the DC-DC is even more superior to a traditional solenoid style.
Definitely.
From Dave at 9:51 a.m.
Hey Jess, happy Friday.
I know we talked earlier about needing those reports by week's end. Please circle back on those. Thanks.
Yeah, that's really helpful. And a lot of them, not all DC to DC chargers, but a lot of them do integrate solar as well.
Yeah.
What are some of the features that you believe are important in a DC to DC charger that also includes solar? What are you looking for on that?
Well, I want an inbuilt start battery isolator.
Okay.
I want some sort of algorithm there to protect my start battery from over discharge. Because when I turn the truck off, I don't want that DC-DC charger continuing to draw power from my start battery.
Got it.
And so it's got to do that, but it's got to be smart enough to know that when I'm driving down the road that the vehicle is still, and the alternator reduces its voltage output. I don't want the DC-DC charger to all of a sudden turn off because it thinks the truck's turned off.
That's right.
You need to have a smart charging system.
Got it.
So it's really important that you can allow for every type of alternator or charging system, whether it's standard or some sort of smart alternator. Having a solar input as well as the DC-DC charging is simply, two things, two matches made in heaven when we're overlanding.
Sure.
We don't necessarily have the ability to plug into shore power, but we certainly have power from our vehicle and a solar panel.
That's right.
So these are two really important features. And size of the unit. And, the physical size, the space in which it takes up. I mean, we have a 25 amp charger and a 50 amp charger, which are identical size.
Yeah. That's pretty cool.
Yeah. So it doesn't take up any more space to get you more power.
Oh, that's interesting. So if somebody needed to upgrade, they could just swap out the unit in the same mounting location.
Yeah.
They may need to change the diameter of the wire or something, but that's about it.
Listen, if you need more, you can parallel. Some of these systems allow you to parallel them together to give you even more
interesting.
power.
So then you could get up to 100 or something like that.
Yes,
Maybe you had a big battery array.
Yeah.
And are you
1,080 amp hours?
Yeah, exactly like in this trailer that we're in right now. Exactly. Yeah. So are you finding that people are going with larger and larger house batteries and they need that kind of capacity?
Oh, absolutely. Yeah, because they want more and more creature comforts of home.
Yeah.
They want air conditioning systems. Yeah. They want, inductive cooktops.
Yeah.
They want coffee machines.
Yeah, sure.
And maybe this is a good example for us to talk about coffee machines. And what's it going to take to run a coffee machine?
That's a great example. Let's do that.
Okay. Yeah. So let's say your coffee machine draws 1,500 watts. So using Ohm's law, which is watts divided by volts equals current. So 1,500 watts divided by 12 is 125 amps.
Yep.
So to run that coffee machine at 1,500 watts, it's 125 amps from my battery. If that coffee machine was left on making coffees for an hour, that's 125 amp hours. That's a lot of energy.
That's a lot of energy.
Well, we're not making coffee for an hour.
No.
Most
people aren't.
We're making coffee for like 10 minutes. Normally typically it's 2 cups of coffee in the morning for yourself and your partner.
Yeah, sure.
Okay? So let's think about that. So let's take 125 amp hours, which is an hour. Let's divide it by minutes, 60 minutes. So roughly that's 2.08 amp hours per minute. Let's call it 2 amp hours per minute. So 10 minutes times 2 amp hours is 20 amp hours.
That's right.
So I've just consumed 20 amp hours from a 100 amp hour battery to make 2 cups of coffee.
Right. Yeah, so if you like a bunch of cups of coffee in the morning, you're going to go through some energy.
Yes, sir. Yeah.
And the same thing applies for like a blow dryer. Now, obviously, a blow dryer isn't going to be used in my case, but they can be 1,500 watts.
Yeah, they're a heating element.
Yeah.
Anything with a heating element is a lot. Yeah. So using our math just before, if my wife wants to use the hairdryer and it's 1,500 watts, she wants to blow dry her hair for 10 minutes, that's 20 amp hours gone.
Yeah, that's right. Well, and that's 1,500 watts in North American standards, it's at 120 volts.
Yeah.
So you're going through an inverter.
Yeah.
So it's actually significantly more.
Possibly, yeah. Yeah, possibly, yeah.
Yeah, interesting. Yeah, because you get the parasitic loss and everything else like that.
Oh, look, inverters aren't 100% efficient, no matter how good your inverters are. So another rule I go by is to allow for some losses in the equation, rather than dividing by 12, let's divide it by 10.
Yeah,
it's a lot easier for us to calculate, right?
That's sure.
So 1500 divided by 10 is 150.
That's a
so
lot.
150 amp hours in an hour.
That's right. You can burn through a lot.
Yeah,
you can burn
definitely.
through a lot. And but it helps when we do those calculations. It helps us be mindful of how we start stacking them on top of each other.
Yeah.
So maybe you do certain things, and like maybe you use the Starlink in the afternoon, and you use the coffee maker in the morning.
Yep.
You get some solar charge during the day, and then you fire up the Starlink to do a little bit of work for a couple hours in the afternoon.
Definitely. And microwaves.
Yeah.
Microwave ovens.
Yeah,
Like, microwave ovens are sold in their cooking power capacity.
Yeah.
So, this is a classic example. A customer will come to me and say, I want to run a microwave. How big is your microwave? Oh, it's 900 watts. Oh, okay, so you need a 2,000 watt inverter. No, I don't. I only need a 1,000 watt inverter. That'll be plenty. Sir, I need you to go to your microwave and have a look at that tag on the back.
That's right.
So the general rule of thumb I go by is double your cooking power will give you the wattage required to run the microwave.
And that would need to be your continuous power in your inverter. So inverters will normally have two specifications. Yeah. They'll have like a startup or a momentary, and then they'll have a running
like
wattage.
A constant and a surge capacity. Yeah.
Yeah, and we can talk about inverters here a little bit, because I think we got a good understanding of a basic system that most people need. But the reality is that there are a lot of things that we use that require an inverter.
Yes.
So, what do you like to look for using that same example? You know, somebody in a Land Cruiser wagon with that system. What kind of an inverter would you recommend?
Well, you've got to start with, it must be a pure sine wave.
Exactly.
You know, hey, look, the cheaper inverters out there are what they call a modified sine wave. It's like a dirty power. Mm-hmm. A pure sine wave will replicate the energy that you get out of the wall of your home. Mm-hmm. So it's how the AC accessory that you want to power, it was how the manufacturer intended it to be powered, using a pure sine wave inverter.
And if I understand it, and this, maybe you could expand on this a little bit, it's the problem comes that you're bringing in DC power and you're converting it and inverting it to AC power.
Yeah.
And that's how you get these irregular sine waves that can do some damage to sensitive electronics.
Yeah. So look, there's some battery chargers that won't work on a modified sine wave, or there are some like power packs like for computers.
Sure.
That when they run on a modified sine wave, they get really hot.
They do. I've noticed that.
Yeah, but when you plug them into a pure sine wave, they run quite cool.
Yeah, sure.
Yeah, so I liken it to running down the street and only being able to breathe through a snorkel.
Or a straw.
Or a straw, right? Like, you can do it, but you're going to get really hot and wear out prematurely.
Yeah, sure.
But if you take that straw away and you've got all this clean air, you're going to be able to run for miles.
Do you speak for yourself?
Oh, well, someone else.
And one time I remember I plugged in my MacBook into one of those cheap inverters, and I actually felt the MacBook was like, it was like it was buzzing almost. Yeah. It had this really weird, it wasn't getting electrocuted, but it had a really weird kind of resonance in the case.
Yeah.
Something wasn't right.
No, it's a dirty power.
Yeah.
So you got to make sure it's a pure sine wave. You got to make sure that if you've got a 1500 watt coffee machine, you don't go for a 1500 watt inverter.
So probably at least 2,000 watts.
2,000 watts. You've got to give yourself a bit of headroom.
Yeah.
Because these coffee machines, as the manufacturer might say that it's a 1,500 watt power consumption, that's probably at a certain temperature.
Yeah, sure.
and I'll use Celsius here, forgive me.
Yeah, please.
So the manufacturer, like with batteries, for example.
I'm not advocating for Fahrenheit at all.
No.
Celsius makes so much sense. Yeah. 0 is freezing, 100 is boiling. It makes so much sense. Yeah. I don't even understand how Fahrenheit works.
So as an example, battery manufacturers will specify their current capacity or their current rating on the input, say for charging, at 25 degrees Celsius.
Sure.
So when a manufacturer will give you their current consumption for their device, it's likely to be at 25 C.
Sure.
But that's quite comfortable. But when we're out overlanding,
sure.
and we're getting into maybe through Arizona or into some of these, through Utah or some of the hotter environments,
sure.
Maybe through Texas or something similar, the product's likely going to draw a little bit more.
Oh, sure.
Right, so you've got to give yourself a little bit of headroom.
Yeah.
It's like when we put a fuse in a circuit. You know, the rating of the system, it might be a 50 amp charger.
Yeah.
We don't go putting in a 50 amp fuse.
No.
We put in like a 60 amp fuse.
Sure.
We've got to give ourselves a bit of headroom.
And I've also noticed in installations that people will put inverters in these really small enclosures.
Yeah.
And that's, in my experience, that's a bad
It is.
thing, because they have many of the larger ones will have fans on them. They're trying to get some airflow, so it's not a good idea to shove your inverter in a box or in a drawer or in some kind. Yeah, you want to give it some airflow.
Yeah, you know, when these things are working hard, they're going to create a lot of heat into conversion to give you the power that you need.
That's right.
So well ventilated. And just allow a clean flow of cool air to run across it. That's really important.
Yeah, I would agree. All right, well, let's pivot the conversation a little. This has been hugely informative. Let's pivot the conversation a little bit to best practices around installation, types of wire, quality of components, things that you've seen in your 35 years of a career in this world, where you see people making mistakes and when you see people making things done right. So talk us through installation, quality of installation,
Sure.
some best practices.
Okay, one of the most common thing I see, in particular in the US, is consumers are using circuit breakers for battery charging circuits. Circuit breakers, no matter how good the quality is, they are a high resistant connection. They're a bimetal strip. When they get too hot, they open circuit. So for DC-DC charging circuit, with the constant current associated with these DC-DC charging circuits, circuit breakers aren't necessarily, compatible with those type of circuits. And they get really hot. There's a lot of losses in them. And they can cause and or burn out prematurely or cause lack of energy to get to the source or to get to the destination. Yeah.
So you'll use a glass fuse or a...
No.
What will you use?
I recommend a low resistant fuse that has a really good fuse holder. So
we're talking cinched down, nice.
We can bolt it down. Something that you can bolt down, like a MIDI fuse, MIDI, or a mega fuse, MEGA.
Okay.
Right. They're the recommended fuses for DC-DC charging circuits. Now, depending on the size of the circuit, will depend on the type and or the size of the fuse. But these are the type of fuses that we get to bolt into a fuse holder, bolt on your cable, and tighten it down nice and tight.
So then you're not getting any interruption in that circuit. You're not getting high vibration.
No,
it's not going anywhere. A little dab of anti-seize on there.
Moisture, vibration. It doesn't matter. Where I can't say the same for some of these circuit breakers.
Well, and that's so interesting that you say that, because you'll even see installers that are considered of high quality, and they'll use a lot of circuit breakers.
Yeah.
Probably because it's cheap and it solves a couple problems. You're like, I can just disconnect this circuit real quick. You can still do that with a fuse. It's just going to take you another 30 seconds with your Allen wrench, and you remove the fuse if you need to isolate the circuit.
Right.
That's really great feedback.
Yeah.
Now, what do you find that you like for... Because this is something that I am asking you the question around. What do you like for battery terminals? Are there any brands that you like, or are there any types of battery terminals that you find are great? Because I've seen 1,000 different options.
Yeah, look, now with the number of these auxiliary battery systems that come out to the market, they allow you a couple of different methods to attach cabling.
Yeah.
So if you're going to use the regular clamp style battery terminal, where you have the terminal, you put the clamp over it and you do it up nice and tight. On the other side, the saddle mount type battery terminals aren't necessarily the best to go, because they're sort of like just clamping down.
Got it.
Not too dissimilar to like a blade type fuse.
Sure.
Where, that's another type of fuse sometimes I see in DC charging circuits, which isn't a good idea.
Got it.
Because, we push that fuse into that holder, and it's essentially a sprung connection.
Yeah.
So with all that current passing through it, the metal heats up and the metal expands. The more it heats up, the more it expands, the more resistance it creates.
Sure.
And all of a sudden, you've melted the fuse. You haven't blown the fuse. You've just melted it. And then that's gone open circuit.
Yeah.
So a fuse and a fuse holder that offers the least amount of resistance. And then it comes on to cabling.
Yeah.
Cabling is important. So the smaller the cable that we apply to the circuit, the harder the product's got to work to operate.
Well, it's like pushing water through a small diameter hose in your garden.
Yeah.
You're just not going to get a lot of flow.
And with the DC chargers, they're going to pull that power through. So they're going to cause a lot of heat in that cabling. So the sizing of your cabling is really important. So look to the manufacturer, to their recommendations. I used to write an article for a magazine in Australia, and I used to talk about losses on cabling, and I gave examples on the different size of cable versus the length, because the longer the length, the bigger the cable we got to go. But it's really important for the DC charging circuit. Go the biggest cable you can get, because that's going to offer you the most efficient.
They look cool.
It's cool. Yeah. Big cable's always good. Right?
And also just like taking the time to be mindful about your installation.
Yeah.
You see in a lot of people's vehicles, they start off with one system, and then they add this other thing, and then they add solar, and then they add their coffee maker, and then they add S-Pod, and they add all these different things on top of it, and it looks like a spaghetti mess just waiting for a fire. Yeah. So every time that you go to start a system, think about all the things you may want to add in the future, and make sure that you're set up to be able to integrate those. And that means like going with the right kind of holders. Go with the fuse holders that maybe have a couple open positions for the future, for you to kind of future-proof your installations, keeping the wiring away from moving components in the engine bay. And away from heat from the exhaust, because the insulation will get hot, it'll get cracked and brittle, it'll get hard, and then it can split. And any number of things can happen. I mean, I've seen electrical cables fall into pulleys and get, the pulley goes through it, next thing, all that stuff.
Terrible, yeah.
Yeah, and those things can happen. So that's really good feedback around the quality of the cabling as well.
The time and money spent on the installation will prove paramount to product longevity and performance.
Yeah.
So you don't want to be that guy who's, a week into his trip, hundreds of miles away from home, and then having problems, thinking, maybe I should have used, or maybe I shouldn't have used that blade fuse holder or that circuit breaker, because now I'm having trouble. So spend a little bit more money, spend a little bit more time on doing the job properly, or having the job done properly by a professional, because that's going to prove, it's going to prove so much more successful when you're down the road and you're having trouble-free overlanding.
And what I would recommend, if you have an installer do these systems, which there's nothing wrong with it, I think it's a good idea, make sure that when you sit down with the installer, you say, I'm going to pay you for the time that it takes for you to draw a schematic of what you're installing, so that way when I pick the vehicle up, I have the schematic of what you've done. And then I'm also going to pay you the time necessary to label each one of the circuits at both ends of the cable.
Yeah, that's important.
So that way you know that this wire is the one that goes to the DC charger, not the one that goes to the dual air compressor.
No.
Otherwise, how do you know?
Yeah.
So when you have that stuff installed, put the expectation, you need to pay your installer fairly, but say, I'm I'm going to use this vehicle on a long trip. It's really important that I'm able to service it myself or have someone else service it. So I need you to label all the wires, and I need a complete schematic of what you've done.
And carry spares.
Yeah, that's right.
Carry some spare fuses.
And some spare length of wire and connections. And
it's also important, equip yourself with some basic utensils.
Yeah.
With some basic tools.
Yeah.
A test light.
Yeah.
Or an inexpensive multimeter.
Yeah.
Because if you phone up tech support, let's say for the company that I work for, and you phone our guys or myself, I'm going to want to know. I want you to do some checking for me,
right.
so I can help you get out of trouble.
Yep.
So if you're equipped with some basic tools, you could save yourself a lot of money.
You absolutely could.
Yeah.
I also wanted to take a brief moment to thank all of you for listening to the Overland Journal podcast. By listening to this podcast and subscribing to the Overland Journal magazine, you're supporting our employee-owned and veteran-owned business. Impartial reviews and in-depth content like this would not be possible without your support. If you enjoy the podcast, I think you'd really love the print magazine as well. And 100% of that subscription price goes back into creating the content like you're listening to right now. And as a special thank you for your loyalty, we're giving 20% off any subscription. And that even includes our special lifetime subscription, which includes numerous lifetime-only benefits. You can go to overlandjournal.com and use the code OverlandPodcast at checkout. Again, that's code OverlandPodcast at checkout, and that'll give you 20% off. I sincerely appreciate your support. Mark, this has been a fantastic conversation.
Thanks, Scott.
You have a great reputation in the industry.
Thank you.
We intentionally didn't talk much about the company that you work for, being Red Arc. Red Arc is a highly respected organization. The fact that they have someone like you on staff speaks to their intention around quality. There's lots of great other companies on the market too, so we're not at all saying that that Red Arc is an N of one, but you spending the time with us today, sharing your knowledge around electrical systems. I have to say that in my experience, the most common failure of an overland vehicle is a flat. The second most common failure of an overland vehicle is the electrical systems. And that's usually because they're poorly installed. So people, they're frustrated because their food is getting hot and their fridge isn't working, or something, they smell electrical current burning in the vehicle. This can be very unsettling for people. So we've talked a lot about best practice in this podcast, the foundation of a great electrical system. And you guys, if I remember, you guys also have good information on your website as well.
Yeah.
So there's some really good educational resources available on Red Arc, the Red Arc website, that you can find out more information about how to set these systems up properly.
Definitely, 100%. Yeah.
Yeah. Well, Mark Brucey, thank you so much for your time, man. Appreciate it, buddy.
Yeah, no worries.
We thank you all for listening, and we'll talk to you next time.
Thank you.